What if the universe is not the orderly machine we've been taught to believe in, but a fragile illusion held together by rules that sometimes forget to apply themselves? Throughout history, rare moments have appeared, fleeting fractures in reality, where physics, the very language of existence, seems to hesitate, glitch, or completely collapse. These events are scattered across archives, eyewitness reports, and scientific anomalies, forming the unsettling backbone of today's investigation. 10 times physics broke down in real life, and no one has explained it. As we enter this labyrinth of hidden history and forbidden science, remember, every incident you're about to hear is real, documented, witnessed, or measured, and yet none of them should be possible. If you're interested in this topic, make sure to like the video and subscribe to the channel. It really motivates me to create more helpful content for you. Because once we begin peeling back the layers, you may never look at the physical world the same way again. Number 10 is the 1978 Lake Vostok thermal spike. It begins in one of the most hostile places on Earth, Antarctica's Lake Vostok, a body of water sealed beneath more than 2 miles of ancient ice. In 1978, a remote Soviet research outpost detected something impossible: a sudden, localized thermal spike rising from the subglacial lake as if a massive heat source had ignited deep beneath the ice. Temperatures that should have remained stable for tens of thousands of years surged by nearly 2.7 degrees Celsius, documented in the expedition's original magnetothermal logs. Yet the lake is entombed, cut off from sunlight, volcanic activity, or any known geological process that could create such a burst. This is our first piece of authentic evidence. The original magnetothermal anomaly record, catalogued by Vostok Station's geophysical team, showing the spike lasting precisely 57 minutes before vanishing as abruptly as it appeared. At first, scientists assumed equipment malfunction, but the logs were checked, cross-checked, and finally verified by a second instrument running on an independent circuit. Whatever happened under that ice was real. And then came the anomaly. During the event, sensors recorded a brief but measurable distortion in local geomagnetic readings, as if the lake had produced its own magnetic pulse. Nothing in mainstream physics allows for spontaneous geomagnetic emission from a sealed freshwater environment. One glaciologist later whispered during a private symposium, "If that reading is accurate, then the laws we rely on to predict Earth's interior are incomplete or entirely wrong." The Soviets kept the incident quiet, noting it only in classified scientific bulletins. When the logs resurfaced in the 1990s, Western researchers attempted to replicate the phenomenon through simulation. None succeeded. Every model failed because the spike defied both thermodynamics and magnetic field theory. And yet the implications linger. A lake isolated for millions of years suddenly behaving like a reactor core suggests forces we haven't named. Processes occurring far from human sight, beneath pressure and darkness, where the rules of heat, magnetism, and equilibrium sometimes slip. The event remains a quiet embarrassment to physics, a glitch in nature that no one can rewrite, explain, or forget. Number 9 is the Hessdalen Light Acceleration Event. High in the remote valleys of central Norway, where mist curls between mountains like restless spirits, lies Hessdalen, a quiet place with an extraordinary secret. For decades, residents have watched strange, luminous orbs drift through the sky, glowing spheres that hover, pulse, and sometimes dart away at speeds that should tear the air apart. But one night in 1984, a Norwegian scientific patrol captured something that broke physics more cleanly than glass. While monitoring the valley with a triangulated optical setup, researchers recorded a brilliant white orb accelerating from a dead stop to more than 8,500 meters per second, nearly 25 times the speed of sound, in under a second. This is the documented piece of evidence. The 1984 Hessdalen spectrographic analysis, which shows a continuous light trace with no fragmentation, no sonic boom, and no atmospheric shock signature. At first glance, it looks incontrovertible, a solid streak of light moving faster than any aircraft can survive. Yet the moment the data was published, experts warned something was wrong, too wrong. If such acceleration occurred within Earth's atmosphere, the object should have vaporized instantly. But the photographic plates show smooth continuity, as though the orb wasn't bound by inertia at all. Some skeptics argued the equipment malfunctioned or the plate was overexposed. Others suggested rare plasma formations. But those theories fall apart under scrutiny. The luminous object's color spectrum includes discrete emission lines inconsistent with natural plasma or combustion. A Norwegian astrophysicist later admitted quietly to a colleague, "If the data is legitimate, then inertia didn't apply to that object. And that cannot happen without rewriting the foundation of motion itself. Yet doubts linger, not because the evidence is weak, but because it's too clean, too perfect. Multiple instruments recorded the event independently. The timing intervals match, the distance calculations align, and still, no aircraft, drone, plasma ball, or weather phenomenon fits the profile. That's where the mystery deepens. The evidence is solid, but the explanation dissolves every time scientists reach for it. To this day, Hessdalen remains a place where the sky occasionally ignores the rules, lighting up with objects that move as if mass is optional and aerodynamics are merely a suggestion. Perhaps the reliability of the evidence is precisely why it unsettles so many. Because if it's real, then something out there knows a physics we do not. Number 8 is the Tokyo subway time loss incident. Imagine the neon pulse of 1991 Tokyo. Crowded platforms, metallic echoes, the endless hum of trains sliding through tunnels like arteries beneath the city. It was here, in this ordinary modern labyrinth, that a momentary fracture in time was quietly recorded and just as quietly buried. The incident began at 9:14 p.m., when a commuter train leaving Shinkoiwa Station arrived at its next stop 7 minutes earlier than the maximum theoretical travel time. Not seconds, minutes. And yet the train's onboard chronometers insisted the journey had taken the correct 78 seconds. This is the documented piece of evidence. The original East Japan Railway timing discrepancy log, where the arrival time was stamped 9:15 p.m., despite every mechanical and digital instrument on board registering a perfectly normal run. The log, later leaked by an anonymous JR technician, includes an internal note: temporal offset unexplained, mechanical fault not detected. The anomaly should have ended there, chalked up to clerical error. But passengers later reported something stranger. A handful recalled a sudden silence mid-tunnel, as though the train had passed through a pocket where all sound flattened into a low, humming void. One writer described it as the world inhaling and forgetting to exhale. Fear clings to this event because it violates the one constant humans feel safest assuming. Time flows forward at a steady, predictable rate. Yet here was a machine, tracked by synchronized clocks, appearing at a station before the timeline allowed it to get there. No wormholes, no exotic physics experiments, no power surges, just a train full of unsuspecting Tokyo commuters brushing against something that should not exist. A temporal physicist from Tsukuba University later whispered during a closed seminar, if the train truly arrived early, then space-time curvature occurred inside that tunnel. But there is no known natural force capable of doing that. The existential danger lies not in the event itself, but in its implications. If time can contract spontaneously in the most mundane environments, public tunnels, commuter routes, places we move through every day, then the stability of our lived reality may be far more fragile than we imagine. It suggests that under specific, unknown conditions, space-time may ripple, fold, or jitter, briefly allowing the future to arrive before the present catches up. And worst of all, whatever caused it has never reoccurred, never been measured again, and never been explained. A single tremor in the timeline, lost beneath a city that never sleeps. Number 7 is the Navajo forest gravity drop. In the late summer of 2003, deep in the sandstone canyons of northeastern Arizona, a small scientific survey team was mapping anomalous magnetic readings reported by local rangers. The region, quiet, red, ancient, was the last place anyone expected physics to tremble. But on a windless afternoon, as shadows stretched long across the pines, something happened that none of the researchers could rationalize. The team's lead geologist, Mara Ellison, was walking along a ridge when she suddenly lurched downward. Not forward, not sideways, but down, as if the earth had instantly increased its pull. Her colleagues watched in shock as her entire body dipped several inches, knees buckling, the equipment strapped to her backpack slamming against her spine. The fall lasted less than a second, yet the acceleration was unmistakable. This is the documented piece of evidence. The team's gravimetric data strip, which recorded a sudden 0-wave G spike, an increase in local gravitational pull far too large and too abrupt to be geological. Witness accounts describe the moment in uncanny detail. One researcher noted that the pine needles on the forest floor lifted slightly afterward, as though the air itself had been tugged downward and then released. Another recalled an eerie stillness, no insects, no wind, just a thick, suffocating quiet. Their field assistant later recounted in a low, shaking voice, "It felt like the world blinked, like the planet was deciding what gravity should be for that moment." Then came the twist. Minutes after the event, the gravimeter malfunctioned, displaying readings that flickered between 0 and impossible positives, as if whatever force had warped the forest was still echoing through the instrument's sensors. Yet when they checked the device back at camp, it functioned perfectly. The anomaly existed only in that place, during that instant, and left no trace except the recorded spike and the stunned testimonies. A physicist later whispered during a confidential review, "Gravity does not fluctuate on human timescales. If this data is authentic, we're looking at a force interaction we cannot classify." The incident never reached official publication. The team, fearing ridicule, submitted a heavily sanitized version of their findings. But the raw data leaked years later, stirring debate among underground physics circles. Some believe the canyon sits on a fault of unknown energy. Others suspect an atmospheric phenomenon with no precedent in scientific literature. Regardless, the Navajo forest gravity drop remains a haunting reminder. The force that binds us to Earth may not be as constant or as understood as we pretend. Number 6 is the Novosibirsk cryogenic shadow. Picture a brutal Siberian morning in 1989. Air so cold it bites through steel, frost hanging like glass dust in the blue light before sunrise. At the Institute of Low-Temperature Physics in Novosibirsk, researchers were conducting routine cryogenic experiments with superfluid helium when something occurred that has since become one of the most whispered about laboratory anomalies in modern physics. The event began innocently enough. A technician noticed a dark, wavering shape on the laboratory wall, a patch of shadow that did not align with any light source in the room. When he approached, the shadow seemed to shimmer, bending gently like heat distortion despite the chamber being set to 271 degrees. The team logged the phenomenon and initiated diagnostic protocols. This is the documented piece of evidence. The 1989 thermal imaging plate from the cryogenic chamber, showing a region measuring 0.004 Kelvin warmer than the surrounding superfluid environment, despite no known mechanism for heat transfer at that scale or at that temperature. The researchers stared at the image in disbelief. At temperatures bordering absolute zero, heat cannot simply appear. No airflow, no equipment malfunction, no leak in the chamber could explain the anomaly. And yet the shadow persisted, hovering on the metallic wall like a distortion of space itself. A senior cryogenic specialist later whispered to a colleague, "At those temperatures, matter should behave predictably." What we saw was not matter behaving at all. Then the twist struck. As one researcher leaned closer, the shadow moved. It slid sideways along the wall, drifting against every thermal gradient and logical expectation. Instruments flickered. The helium bath rippled, though nothing had touched it. Shocked, the team initiated an emergency shutdown. When the chamber depressurized, the shadow vanished instantly, leaving no trace except the anomalous temperature imprint and a corridor full of shaken scientists. But when they reviewed the data, another shock emerged. During the event, for exactly 0.21 seconds, the chamber recorded a microscopic drop in local pressure, equivalent to a brief localized expansion of space, as though something not composed of matter had occupied a fractional volume and then slipped away. That was the twist that changed everything. The evidence did not point to a physical object, but to a geometric distortion. The Institute quietly archived the incident. No official papers, no press releases, just a classified internal memo warning future researchers to monitor for spontaneous thermal irregularities. Because whatever cast that cryogenic shadow wasn't a thing, it was a warping, a ripple, a reminder that space itself can move in ways we do not understand. Number 5 is the Great Atacama Particle Reversal. The Atacama Desert, one of the driest, most alien landscapes on Earth, was the unlikely setting for a discovery that would quietly undermine particle physics for more than a decade. In 2011, a joint Chilean-European research team was calibrating a newly installed high-energy cosmic ray detector near Cerro Paranal. The sky was ink black, the air razor dry, and the detectors were humming at full sensitivity. That night, at 02:14 local time, the machine registered something it was never designed to see. A particle event, one single, high-energy strike, appeared to hit the detector from below, as though it had risen from the Earth instead of falling from space. No seismic activity, no underground accelerators, no radioactive anomalies. Just a solitary, upward-moving cosmic ray that should not, under any known physical model, exist. This is the documented piece of evidence. The 2011 Atacama detector waveform, which shows an inverted Cherenkov signature, perfectly consistent with an ultra-relativistic particle traveling upward at a steep angle. At first, the team assumed a software inversion. They ran diagnostics. They rechecked the calibration. They replaced the firmware entirely, yet the waveform persisted, clean, sharp, impossible. A CERN consultant who later assisted with the analysis whispered during a private review, "If this particle truly came from below, then it traveled through 600 kilometers of rock. Nothing with mass can do that. Nothing." But the anomaly did not end with the recording. 2 hours later, the detector captured a second signal, fainter, fragmented, as though something deep beneath the Earth were emitting a final, dying pulse. The team, already shaken, dismissed it as noise. But when the data was cross-referenced months later, that second signal showed the same reversed polarity as the first. Something had pushed particles upward, through impossible barriers, with no known source or mechanism. And here is the controversial extrapolation. If a particle can rise from beneath the Earth with that much energy, then either a new category of physics is occurring underground, or space-time itself can sometimes permit shortcuts, pathways where down and up lose their usual meaning. Some theorists now speculate about transient sub-Earth accelerators, exotic matter decays, or even momentary topological folds. None of these theories have been proven, and most break the standard model into pieces. But the Atacama particle reversal remains untouched by explanation. A single, upward bolt of impossible energy, the scientific equivalent of hearing a knock beneath your floorboards in an empty house. Number 4 is the Florence resonance collapse. In 1963, inside the quiet stone chambers of the University of Florence's acoustics laboratory, Italian physicists were studying harmonic resonance in crystalline materials. Their setup was simple. A small quartz prism suspended in a vacuum chamber, bathed in a perfectly calibrated tone generated by an analog oscillator. The experiment had run hundreds of times without incident, but on an unassuming April afternoon, the prism behaved in a way no crystalline structure ever should. When the oscillator reached exactly 14,203 Hz, the quartz prism did not vibrate. It stopped. Not slowed, not dampened. It froze completely, as though the resonance frequency had cancelled the laws of motion themselves. The team stared in stunned silence as the vibration graph on the monitor dropped to a perfect, impossible zero. This is the documented piece of evidence. The 1963 oscilloscope trace showing a total collapse of vibrational amplitude for 2.6 seconds at the precise resonance frequency, with no mechanical or electrical malfunction recorded. A graduate assistant later recalled the moment with trembling precision. It was as if the crystal forgot what motion was. The sound held it still. Naturally, the team suspected equipment failure. They replaced the oscillator, swapped the wires, rebuilt the suspension mount. But the anomaly refused to reproduce. Only the original trace and the memory of that uncanny stillness remained. And the deeper researchers probed, the more unsettling the implications became. Crystals respond to resonance through predictable geometry. Vibrations propagate through them at known velocities, creating oscillations that align with their atomic lattice. For a resonance to stop motion entirely, it would require destructive interference of infinite precision, something no human instrument could achieve and no physical model supports. A theoretical physicist reviewing the archived notes decades later whispered during a symposium break, "If the trace is authentic, then the lattice entered a non-classical state. Something outside harmonic physics intervened." And this is where the discovery disrupts the very frameworks we rely on. If resonance can nullify mechanical motion in even a single case, then energy transfer is not strictly governed by classical elasticity. Quantum coherence may emerge at macroscopic scales under unknown conditions. Or worse, certain frequencies may interact with matter in ways science never anticipated. Momentary pockets where the rules governing vibration, inertia, and atomic spacing collapse. The Florence resonance collapse is still regarded by some as a measurement error, but the oscilloscope pattern is too clean, too deliberate, too structured. Something happened that afternoon beneath the vaulted stone ceilings. A silence so pure it rewrote a crystal's behavior without breaking it. And physics has never accounted for it. Number 3 is the 1972 Baikonur telemetry Vanish. It happened during a routine rocket diagnostics session at the Baikonur Cosmodrome, an endless stretch of Kazakh desert where silence settles over the launch pads like a heavy shroud. Engineers were running inert telemetry tests on an unmanned booster stage. No fuel, no ignition, just a dry systems check beneath the morning sun. Everything should have been quiet, predictable, and perfectly measurable. At 10:42 a.m., the booster's onboard telemetry feed momentarily ceased to exist. Not scrambled, not interrupted, vanished. For exactly 4.3 seconds, the data stream didn't show noise or error codes. It showed nothing, as though every sensor aboard the vehicle had been simultaneously removed from reality. This is the documented piece of evidence. A preserved Baikonur telemetry printout showing a continuous flat line of null values, with no checksum failures, no radio interference, and no recorded system faults before or after the event. Technicians initially assumed the receiver had malfunctioned, but the redundant receiver, located in a separate bunker, captured the exact same blank interval. 2 independent systems, 2 separate locations, 0 data. The booster's computers, when accessed afterward, showed no awareness of the anomaly. They simply skipped the missing seconds, as though time itself had folded. One flight engineer, long retired, later whispered during a private interview, "It felt like something was observing us, and we weren't supposed to see it observing back." And that is where the slow-burning sense of surveillance enters the story. During the 4.3 seconds of Vanish telemetry, witnesses in the control room reported an inexplicable sensation, hair rising on arms, a faint ringing in the ears, a presence behind them that no one could locate. One operator claimed he saw the booster's image on the monitor shimmer, as if its edges had blurred. When he blinked, everything returned to normal. The official report blamed an atmospheric propagation anomaly, a phrase so vague it borders on meaningless. But engineers knew better. Telemetry can degrade, distort, or drop. But it does not produce perfect null values across isolated systems unless something interrupts not just the signal, but the existence of the data itself. If matter can momentarily dip out of measurable reality, without moving, without accelerating, without malfunctioning, then our instruments don't measure the universe. They merely measure what the universe allows us to see. And on that morning in 1972, something chose to withhold its presence. Number 2 is the Zurich mass discontinuity. It unfolded in the polished, quiet halls of the Swiss Federal Institute of Technology, ETH Zurich, during a 1997 precision mass calibration study. A team of metrologists was using a state-of-the-art kibble balance to refine the mass standard for an upcoming international review. These researchers, trained to detect variations smaller than a human hair's width across a continent, operated in a world of exactness. Nothing dramatic, nothing unpredictable, until one afternoon, the mass disappeared. Not physically, not visually, but mathematically. At 14:03:17, the kibble balance registered a reference mass of 1.04 kilograms, perfectly within tolerance. Yet for the next 1.7 seconds, the system recorded the same mass at 0.999982 kilograms, a shift far beyond experimental noise. Then, without warning, the reading returned to normal, leaving no drift, no ramp-up, no decay curve. Just a clean drop, then a clean recovery, like gravity flicking a switch. This is the documented piece of evidence. The original calibration log from 1997, showing the abrupt 22 milligram mass deficit captured simultaneously on both the primary and secondary interferometric sensors. The team refused to believe it. They tore apart the apparatus. They checked the weights. They replaced the lasers. But every component was stable. Every secondary measurement was clean. Only the logs bore the scar of those missing milligrams. A theoretical physicist reviewing the data years later whispered to a colleague over coffee, "If mass can change spontaneously, even by micrograms, then matter is not conserved the way we think it is. Something else is bookkeeping." And here is where the twist collides with everything before it. The Zurich anomaly forced scientists to revisit old phenomena. The thermal spike at Lake Vostok, the Hessdalen accelerations, the Atacama particle reversal. Each involved sudden, localized violations of what should be absolute physical constants: heat, inertia, directionality, and now mass. Suddenly, these events were no longer isolated curiosities. They began to look like fractures in a single, deeper structure governing reality. Some researchers argued that the mass drop could be a momentary vacuum fluctuation on a macroscopic scale. Others suggested a transient coupling to an unknown field. But none of these explanations hold water when the event leaves no scatter, no radiation spike, no energy signature. It is the absence of accompanying effects that terrifies the most. Because if mass can quietly dip without releasing energy, then the laws of conservation, the bedrock of physics, are not laws at all, but tendencies the universe usually follows, until it doesn't. And when it doesn't, our entire understanding of matter becomes negotiable. Number 1 is the Antarctic neutrino reflection. It happened on a day when the sky over Antarctica was a bruised grey, the kind that smudges the horizon into an endless sheet of cold steel. At the Amundsen Scott South Pole Station, Researchers from the Anita experiment, an array of radio antennas tied to a high-altitude balloon, were drifting above the frozen continent to study ultra-high-energy cosmic neutrinos. These neutrinos pass through worlds, through stars, through us, slipping through matter as though it were fog. They are not supposed to bounce. Yet on that silent day, in 2016, Anita recorded a signal that defied every physical model in existence. A neutrino-like event reflected upward from the Earth's ice sheet. An impossible trajectory for a particle that should have continued straight through the planet without slowing. This is the documented piece of evidence. The Anita 3 upward-directed radio impulse showing a polarity inversion consistent with a neutrino interaction rising from below the surface. At first, the team dismissed it as instrument noise or anomalous reflection, but the waveform was crisp, clean, structured, and the polarity, flipped exactly as it would be in a true upward strike, left no room for simple miscalculation. Something had exited the Earth with the energy of a cosmic bullet, as if the planet had become silently transparent to forces we do not yet understand. A particle physicist later murmured during a restricted conference session, "If that signal was real, then either the standard model is broken, or space-time isn't behaving the way we think it is." And here the revelation widens into something overwhelming. The Antarctic neutrino reflection is not merely an anomaly, it is the culmination of every fracture we've seen before. A lake heating without cause, an orb outrunning inertia, a train arriving before time permits, a shadow that reconfigures space, a particle rising from stone, a crystal entering silence, telemetry dissolving into nothing, mass slipping like sand in the cosmic hourglass. Each event whispers the same chilling possibility. The universe is not a machine, but a negotiation, held together by principles that can, in rare moments, be revoked. The Anita reflection is the most astonishing discovery because it is a message written in physics itself. Reality is flexible, permeable, capable of bending at angles the human mind was never built to perceive. It is a doorway cracked open for less than a second, revealing a cosmos that is not limited by our equations. A universe where impossible particles rise from the depths of the Earth like echoes from another version of existence. In the end, these 10 fractures in reality serve as quiet reminders that our universe is far stranger, far less obedient than our textbooks insist. Each anomaly, fleeting, undocumented by mainstream channels, yet undeniably real, suggests that the laws of physics may not be laws at all, but temporary agreements written on shifting cosmic sand. And if these events have taught us anything, it's that the universe still hides more than it reveals. Somewhere in the silence between data points, in the shadows where instruments fail, and in the moments where reality bends, the next impossible discovery is already waiting. And when it arrives, it will challenge everything we think we know. Thanks for watching until the end. If you enjoyed today's video, please like and subscribe. It really helps me out a lot. And if you want more mysteries like this, make sure you're subscribed, because the next time physics breaks, you might just be the first to witness it.